Hello, welcome back. Today we're going to learn about lesson 2-2. It's titled Ins and Outs, and we will be learning about inputs, outputs, and interpreting expressions. So expressions are one of our first entries into the algebra world. So where the classwork starts, around the middle of this page, they ask us what we know about variables. So they ask you to define what a variable is. If you scroll down a little bit, he gives us his answer, the author does. If you're like most people, your answer is probably something like this. A variable is a letter instead of a number. And then it's more than that. So we want to say that that's not just what a variable is. I know I have lots of students who tell me I was great at math until we put letters in. So let's deconstruct what a variable is and make it more understandable and a little less intimidating. A variable is simply a quantity that is able to change or vary. So it's a placeholder often. This is contrasted with a constant. A constant can't vary. The number 12 is a constant because no matter what we do, it's always 12. So then we bring up, okay, what is this whole letter thing? So if a variable is just a quantity that can change or vary, what does the letter mean? Isn't X a variable? Technically, the answer is no until we use it to represent a quantity. We use letters to represent variables, since that distinguishes them from numbers, which will never change. But a variable is not necessarily a letter, it's a quantity that can vary, usually represented by a letter. So to save time, we often refer to the letter as a variable. But it's more that idea that something can change. It's a placeholder. It's holding a place for something. Number 2 at the bottom of the page asks us to determine which sentence makes more sense. So sentence A says the amount of time you spend studying depends on the grade you earn in the course. And part B says the grade you earn in the course depends on the amount of time you spend studying. Which one of those makes more sense when you read it out loud? Generally, B is going to make more sense on this one. The grade you earn in the course depends how much time you spend studying. At the top of page 170, they want you to think about some other things that might influence your grade in this course. So we talked about studying. How about attending? Attending is pretty important. Doing all of your homework. Participating, being involved, asking questions when you need it, using the tutoring services if needed. There's lots of things you can do to better your grade. For the most part, if you are attending every class and doing all the work, you should get a passing grade in the class. So below that, they're talking about the idea of dependent versus independent variable. So because these factors can cause a change in your course grade and not the other way around, the course grade is the dependent variable because it depends on what you do in the class. The other factors like the amount of time spent studying, attending class, doing homework, those are things that are within your control, and those are the independent variables. They cause a change in your grade. So your grade depends on all those things we listed in number 3. So we're going to go through several examples and decide which is independent and which is dependent. So 4A says the age of a tree and the height of a tree. So the question here is, does the age of the tree depend on the height, or does the height depend on the age? So saying them out loud generally helps us. And I think it becomes very clear that the height of the tree depends on the age of the tree. So the height is the dependent. Depending on the age of the tree, which is the independent. Let's take a look at B. The number of practice sessions and the quality of a musical performance. So again, let's read that in both directions and see which one makes more sense. Does the number of practice sessions depend on the quality of the musical performance? Or does the musical performance depend on the number of practice sessions? Generally, the second one makes more sense. So your quality of your performance is going to be your dependent. That's that one. And your independent is going to be the number of practice sessions you have. because in general, the more you practice, the better the performance will be. C is one you may be very familiar with. Your score on a placement test and the math courses you've already taken. So does your score on the placement test depend on all the courses you took before, or do the courses you took before depend on your placement test? The second sentence in that case doesn't even make sense. There's no way that something that I take now can impact what I already did. So my score on the placement test is the dependent. And the math courses I've taken are the independent. So generally, the more math courses you've taken, the higher your placement test will be. How about D, your blood pressure and the amount of time you spend exercising each week? Does your blood pressure depend on the amount of time you spend exercising each week? Or does the amount of time you spend exercising depend on your blood pressure? In this one, I could sort of argue both ways, but they have a specific way they do prefer it. Our blood pressure is going to be dependent again. My blood pressure is going to get better if I exercise more generally. So blood pressure is the dependent, the amount of time I spend exercising is the independent. I could argue the other way a little bit, because if I go to my doctor and my blood pressure is high, they might tell me to start exercising more. E says the value of a share of Apple stock and what year it is. So let's look at that and see which way the sentence makes sense. Does the value of the share of Apple stock depend on what year it is? Or does what year it is depend on the value of the share of Apple stock? That's another one where the second sentence does not really make much sense. The year is what it is, but the value of Apple stock is likely going to change with the year. So the value is the dependent. And the year is the independent. The year will cause the change in the stock. All right, we have two more on this page. F says the number of songs that a band sells on iTunes and the amount of money spent on marketing. So again, we'll read both our sentences. Does the number of songs a band sells depend on the amount of money spent marketing? Or does the amount of money spent on marketing depend on the number of songs a band sells? This is one that I can almost argue either way, but there is a better answer. They do want you to see that the number of songs is the dependent. And the amount of money is the independent. You can control how much you're going to spend. The last one on this page is letter G, the cost of a cab ride and the number of miles you're driven. Does the cost of the ride depend on how many miles you've gone? Or does the number of miles you've gone depend on the cost? Generally, the cost is going to depend on how far you have to go. So the cost is the dependent. The cost depends. And the number of miles is the independent. We've got one more on the top of page 171. This one says the number of customers that want to buy a certain product and the price of the product. So again, let's read our sentences both ways. Does the number of customers who want to buy a product depend on the price of the product? Or does the price of the product depend on the number of customers who want to buy it? Anyone ever taken economics? This one can be gone both ways. You can argue it both ways. If you've heard of the supply and demand, that's what we're talking about. So if a price is low, more people will buy it. But if more people want it, the price will go up. So we can argue that one both ways. So we would argue that we can go both ways on letter H. Number 5, towards the middle of this page, talks about some key terms that we're talking about when we're talking about variables. So the first thing we've talked about is an expression. An expression is a combination of variables, constants, using mathematical operations and grouping symbols. He gives some examples. An equation is a statement that two quantities are equal to each other, generally using expressions and an equal sign. It's generally one expression equals another expression. So the difference between an expression and an equation, both of them are made up of variables and constants and operations, but an equation has an equal sign, an expression does not. An equation can be solved, an expression can be evaluated or simplified. A formula is just a special type of equation. A formula is an equation that you may recognize. It's an equation with multiple variables that is used to calculate some quantity. And you may recognize the ones that are given here. The first one is the area of a circle, area equals pi r squared. Second one is the perimeter of a rectangle, P equals 2L plus 2W. And the last one is dealing with simple interest, A equals P plus PRT. So it's still an equation, it's just one that you may recognize. So they're going to give us a special formula, and they're going to tell me what it is. So the formula is right here. They tell me it costs $2 for a cab ride and then $2.50 per mile, which is where they got this equation for cost. This equation says cost equals 2 plus 2.50 m. C represents the cost, m represents the number of miles. And that's the variable thing that may change. We might say that the number of miles is the input and the cost is the output. I've seen these called function machines. So where you put miles in, do something to it, and cost comes out. So number 6 says, using that formula, if we wanted to know the cost of a 7-mile cab ride, we could just replace m with 7 and then calculate it. So you can put into your calculator 2 plus $2.50 times 7, and we get $19.50. Turning the page to the last part of the classwork, page 172. This is the last problem. It says, evaluate the cost formula for m equals 4. So again, our cost was equal to $2 plus $2.50 times the number of miles that we're going to drive. And all you're going to do is replace m with what it's equal to. You're going to replace m with 4. And you'll rewrite the cost equation. 2 plus 2.50 times 4. Now you can throw that in your calculator. 2 plus 250 times 4, and you should get that a 4-mile taxi ride will cost us $12. So you will continue to work with some formulas, equations, and expressions in your group work, and then we'll continue working with algebra throughout the semester.